So we're going to start with graphing these functions that we started like sketching yesterday, but now we've got an inequality sign. So we're also going to shade. Exactly. Okay, real fast. A coordinate to be a solution, it must make a true. Nice job, Coop. True statement when substituted in the problem. Ready, Tay-Tay? If the coordinate does not make a true statement, it is in the, I'm sorry, if it does make a true statement, it is in the shaded region. Love it. Okay, so you guys, we first have to practice graphing this. Are we ready? So what is my parent function here? What's the basic shape of my function going to be? It's an x squared, right? Then you guys, what am I doing with this x squared? I'm taking it to the right. So you guys, let's write ourselves little notes. This is taking it right to. What's this doing? Down 3. Bless you, bud. So we're going to go right to down 3. That is the new vertex of my parabola, of this shape. I know it's got to be the shape. You guys, do you agree? We've taken care of the 2. We've taken care of the -3 by moving that vertex to right and down 3. So all I need to graph now is an x squared. Bless you. An x squared, you guys, act like this is my new origin. In unison, we all got this. If this is my new origin, and I just have to graph x squared, what is 1 squared? 1. So if I go 1 to the right, I go up 1. What is -1 squared? 1. So again, I'm just acting like this is my new origin, and I'm going to plot them just like that 0, 0. What if I went 2 squared, 2 to the right? 2 squared is 4. 1, 2, 3, 4. I'm going to go up 4 from that new origin. What about -2 squared? 4. 1, 2, 3, 4. What about 3 squared? 3 squared is 4, 5, 6, 7, 8, 9. And then really you could go -3 squared is 9, or you could reflect it over. You could say, all right, if I went 3 from the right of the vertex, I could go 3 from the left. You guys, that's what's giving us our shape. So, solid or dash, solid or dash. Yeah, or if it's less than or equal to, boom. Now, so today we're going to do less sketching and more actual drawing. Like that was a perfect graph. Like we did the actual points. You know what I'm saying? So Blake, we're not going to use our calculators today. We got to do it with our noggin. Okay? Oh, I got you. But we're going to use our noggin. Let's do it. Ready? You guys, if I were to put 3 in for my x, what is 3 minus 2? 1. Square it. 1 minus 3. -2. Is my y of -4 less than or equal to -2? I put my y in for -4, and I put in 3 for x. Is that true or false? -4 is less than -2. So where that is, 3 -4 is down here. If that point is true, you think we should shade down here or no? Yeah. So what that's saying is we should shade down here. Does that seem legit if my original said y is less than all that stuff? Less than is typically underneath. I think that seems fine. Would 4, 7 be in my solution? Oh, really? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Nah, so if I were you, I would just maybe do that. -1, 6. 1, 2, 3, 4, 5, 6. It's that point. Because it's a solid line, can I be on the line? Yeah. And you might be like, well, okay, so these two are all good. And you might think, what if I didn't want to do it on the graph? You could have just plugged it into my function. Is 6 less than or equal to -1 minus 2 squared minus 3? Beck, ready? Some mental math. -1 minus 2. -3, square it. 9 minus 3 is 6 less than or equal to 6. Yeah, so that's how we know it gets to be. What if that was just a less than sign? No, because then it would be dashed and we couldn't be on the line. Cool, cool, cool? Okay, guys, let's practice again how to graph these things. Solid or dashed, first of all? It's going to be dashed. X cubed. Does anyone remember what the X cubed graph looks like? Exactly. Okay, it's going to go from down to up. And where do we need to take this cubed graph? We're going to go right one. Exactly. Then we're going to go down 2. You guys, a cubed graph typically starts at the origin, but I'm going to take that and I'm going to go right 1, down 2. That's my new origin, my new 0, 0. You guys, since I took it right 1 and down 2, you will never use those numbers again. We just have to focus on graphing an x cubed graph, which we haven't done in a long time. Bear with me, ready? If this is my new origin, that's 0, 0. What's 1 cubed? 1. 1 times 1 times 1. So I'm going to go right 1 is 1. What about if that's my origin? If that's my origin, negative 1 cubed. Good. Negative times negative gets me a negative. So I'm going to put that there. Looks pretty linear. What about 2 cubed? 8. 2 to the right of my blue dot, up 1, 2, 3, 4, 5, 6, 7. Right off the graph is 8. I don't have enough space for negative 2 cubed to be negative 8. So that's okay. We're going to just follow this trend, nice and curvy. Oh, I was supposed to make it dashed. Dashed. Oh, gosh, not with the largest eraser ever. Sorry, it's got to be dashed. So we're going to go in. We're going to dash it. Oh, gosh, why is that so big? So we're going to dash, 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 dash. Okay. Pick a point on the graph to help you determine where to shade. Yeah, Mateo. So give me a point that we want to pick.
0, 0.
I agree. 0, 0 is not on my line. Tay, you ready? If I go back to my function, if we're plugging in a 0 for y and a 0 for x, is 0 greater than 0 minus 1 cubed minus 2? Negative 1 cubed minus 2. Is 0 greater than negative 3?
Yes.
Agreed. So this is where 0, 0 was. When it's true, you shade where that point is. So we're going to shade here. Okay, of this guy, what's my parent shape? Absolute value. What does that one look like? Absolute value. Boom. It's the perfect V. Where am I Ooh, I moved things around, you guys. I moved things around. Is this the same as y? Come on, little pen. Okay. Y is greater than. Is that the same as this? Yeah. And sometimes that helps my people see the up and down, left and right a little bit. What's this going to do? Left 2. You guys are good. Bless you. What's this going to do? Up 3. Did you have to rewrite it? Certainly not. But I think sometimes it helps people see it. You guys, what's this going to do? Over the... yeah. So make sure to write those words, Mr. Blake. I know you love words. So you guys, real fast. Boom. We know this is my general shape. Which way am I going? Left 2. Up 3. And then... whoosh. Okay, let's go left 2. Let's go left 2. Up 3. Boom. That's my new vertex. That's my new vertex. I know it's got to be doing like something like this, but I'm not just going to do it all willy-nilly. We got to go facing down. Oh, and we might not know this. You guys, the absolute value graph is always a slope of 1 or negative 1. So it will be a nice V with slopes of 1 and negative 1 until I change that, but we're not going to do that yet. Solid or dashed? Dash that line. Bob, what point do you want me to use as a checker?
0, 0.
And maybe, okay. Let's do 0, 0 because it's right here. If I put a 0, 0 there, I'd get 0 is greater than 3 minus 0 plus 2 is an absolute value bars. What's the absolute value of 2? 2. What's up, Mr. Rediger?
Can you always put 0, 0?
Oh, that's a good call. Yes, unless it was on our line. If it was, if my line went through it, for example, if this was my line.
Okay.
And it went through it, we wouldn't want to use it because it goes through it. We want to know to shade below or above it. But if it doesn't go through it, I think 0, 0 is like the easiest, right? Because I'm throwing zeros in for things. I like it. You guys, is 0 greater than 1?
No.
No. If 0, 0 was here, do I shade there?
No.
No, it was false, so I'm going to shade on the other side of the graph. You got to jump the graph. You guys, does that make sense if my original said, hey, y is greater than that stuff? Greater is typically above. I feel good about it. Bop. Whew. What's going on with this cute little x squared?
You can move it to the left,
Ooh,
to the right.
there's no parentheses.
So,
It's just going to go up 1. Isn't that crazy? This is just going to go up 1. So we have a cute little parabola, up 1. So I'm going to go up 1, boop, that's my new vertex. That's all I'm going to focus on. So now if I took that, I've used it, I just have to graph an x squared. X squared starting there, you guys. So here's where we are. This is my new starting point. If this is my new origin, what's 1 squared?
1.
1. We're going to go boop. What's negative 1 squared? 2 squared. Negative 2 squared. Solid or dashed?
solid.
Yeah. Solid line. And the original said y is less than or equal to. Rediger, do you think we could use 0, 0?
For sure.
For sure. I completely agree. I got to erase what I blacked out over here. Is 0, oops, less than or equal to 0 squared plus 1?
Yes.
Yeah, is 0 less than or equal to 1? And he's like, yeah. So if it is, we're going to shade where the origin is. If it's true, we shade where the origin is. All right, guys, what's my general shape here? Oh, my head itches. A V. What are we doing with the V? Left 4. Taking the V, we're going left 4. 1, 2, 3, 4, boom. That's all we're doing. Opening up or opening down? Up. Slopes of 1 because it's just 1x. Solid or dashed?
Dash.
Good. You guys, I think these are a little easier if we're shading greater than. Do you want me to shade above it or
Yeah.
below it?
Above.
Yeah. And again, a point, you can always check with the point. If I were to say, let's
I
check,
did.
is 0 greater than 4? 0 is not bigger than 4, so I can't shade where the origin is. I'd shade here. What's the general shape of a square root graph? Does anyone remember? It's just, I see it. People are going like this. Boop. I agree. So we got to go do that general shape, but what am I doing with it?
It's negative.
It's negative and
Ooh, it's negative. So we got to reflect over x.
negative
Agreed.
and you need to shift it left by 2.
Left by 2. Awesome, Coop. So you guys, we got to go left 2. If this is x, the square root of x, what's the negative going to make it look like?
Upside down.
Right? So instead of going like this, I'm going to have to go like this. And that's okay. Solid or dashed to prep us? Okay, it's going to be dashed. Let's help ourselves think about this. Ready? I've taken care of the negative by no, I'm going to go down. And I've moved the 2. So I just need to graph square root of x. And I got to know to go down. Square root of 1 to the right of this. Square root of 1 is 1, but I got to do it negative, correct? So I'm going to say when x was 1, I'm going to go down 1. Do I know the square root of 2? Square root of 3? Square root of 4? Square root of 4 is 2, and then since it's negative, I'm going to go down 2. Dashed line, I'm going to go like this. The shading on this one is real sketchy. Ready?
Yeah.
If we got to be greater than this, are we thinking above or below? We're going to go above. You guys, does my graph exist over here? Nope. So when I shade above, I can only go as far left as that origin of negative 2. So just make sure that we do not go any further left than that origin. Okay, let's keep cranking, people. What's my general shape of this one? It's a V. Ooh, okay, Blake, so this is a good one for what we were just asking. What are we doing?
Right, make it skinnier.
We're going right 1. You guys, we're being multiplied by that 2, whoosh, which is going to make it skinnier. Yesterday, we just sketched these. So we're going to make it skinnier, and I'll show you how we're going to do that with an absolute value graph. We got to take my absolute value graph. We're going to go right 1. And instead of just going up 1 over 1, we're going to go up 2 over 1 to make it skinny. Solid or dashed?
It's easy. It's just
It'll be dash.
it's just increasing the slope of the x.
Yep. Shading above or below if it's less than. Below it. Again, we could have used 0, 0. It would have given us a true statement. So we would have known to shade below. Is a V. What are we doing to that V? Up 2. Here we go. We're going up 2. What's the slope going to be?
1.
Yeah, we're back to 1. Solid or dashed? Y is less than or equal to, so above or below? Love. Okay, last one. What are we doing with my parabola? Right 1 and down 2. Right 1, down 2. That's my new origin. We got to graph a parabola. What is 1 squared? 1. Negative 1 squared. 2 squared. Negative 2 squared. And I think that's about as far as many points as we can graph. We're going to draw a nice curved function. Y is less than or equal to. We're going to shade less than. So if I plugged in a 0 there, what's negative 1 squared? Bless you. 1 minus 2 is 0 less than negative 1. Nope. Since it's not, I cannot shade where the origin is, so I'm going to shade outside it. So on the homework, let's do this, 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 this. 5 questions. We've got 7 minutes. You good? And all I want you to do on the top is just tell me if their ordered pair is a solution or not. So yeah, you might be using your calculator on those. That's okay. Maybe not that one. And then graph just these 2.